In our previous videos, we've gone over how you can use pulse and direction to move to a specific position, and we have connected our encoder to our Micro850 and configured a high-speed counter. Before we get started, let's do a little bit of cleaning up on our wiring, because in our first video we used this dial here to show how pulse and direction works. Well, we're not going to use it anymore. So take your wire that is currently going from 1 on one of the dials to the DR plus and remove it. Then take the wire off the other one, which is going to our pulse plus, and let's remove it. And then we actually don't need any power to this. And then pay attention to how you do this, because there is an opportunity here to mess up because we added our encoder to the back of this. Now let's remove the encoder power and hold it in your hand. And then let's remove the jumper wire that is going between these two. Alright, and mainly that should leave you with 3 wires in your hand. Then this wire here, one of them is going to go to this limit switch. So let's remove that. And now we can stick both of those there. All right, let's go over what we got just to make sure that we didn't mess up anything. So we have wires coming from our stepper motor to our stepper driver. And these are A plus to A plus, A minus to A minus, B plus to B plus, and B minus to B minus. Pretty straightforward. Then we have 24 volt coming from our PLC trainer. And the plus of it is going to our stepper power and is going to our limit switch, and is going to the plus of our encoder, and finally it is going to the other limit switch. So we have plus on one side of both limit switches, the encoder and our stepper driver. Then the 0 volt is going to the enable minus, the direction minus, the pulse minus, the ground of our stepper driver, and the ground of our encoder. And we covered all of that in the previous video. Now in this video, we're going to use this left-hand proximity switch for a home switch. So I'm going to take a black wire from the 0 volt and I'm going to jumper it to our ground over here on our stepper driver, or really in the way we wired it, any of the black wires. Then I'm going to connect a wire from the plus of the proc switch, or the V plus, to the plus of the limit switch. And for now, I'm just going to take a wire and I'm going to connect it to the output of that, and that's going to go to our PLC. Then I'm going to connect a wire to the pulse plus, the DIR plus, and without removing our limit switch wire here, we're also going to connect one to our enable plus. And so those 3 wires, along with that proc switch that we're going to use for our home, we're just going to lay over here to go to our PLC trainer. Then in our previous video, we configured our high-speed counter, and if we go to our controller tags, we created our encoder revs, which is the number of revolutions the encoder's made, and then encoder millimeters and encoder inches. So if I rotate this screw, we can see all of those values moving. So in this video, we're going to be working on our motion axis. So we're going to double click on our controller at the very top of the left pane. And this is typically where, when we create a new program, we're going and changing our Ethernet configuration. But a little bit further down, we're going to see motion here, and we have 2 axes here. So I'm going to go offline. And then I'm going to right click the top new axis and click add. And it's going to default to axis 1. I'm just going to name it stepper. And then it's going to have some assignments here to help you figure out where to connect your wires. So first you can select which PTO channel it is, because this Micro850 has 2 of them. And we are going to stick with EM0. And that tells us that our pulse is going to be on output 0 and our direction is going to be on output 3. We also have a drive enable that we are going to use, and it's going to be on output 6. And we're not going to use the drive ready input, so go ahead and uncheck it. That way you have this input free. Now let's think about this one though. So this says drive enable, and it has an active level of high. But if you recall, when we hit one of our limit switches, it sends power to our enable input, and that actually disables the drive, which means this is an active low enable. So we're going to need to change this to active low. Okay, let's go ahead and connect these three outputs. So we're going to be putting our pulse plus to output 0, our direction to output 3, and our enable plus to output 6. So I have my pulse plus, which we did connect to a little bit ago, and it's going to go to output 0. Then we're going to have our direction, and it goes to output 3. And finally, we had the enable, and it's going to go to output 6. So in the end, yours should look like this. We have our PLC power, and then we have COM0 plus, that's going to the plus of our 24 volt power supply. We have output 0, that is going to our pulse plus. And then we have our COM0 minus, that's going to the minus of our power supply. Then we have COM1 plus, that's going to the plus of our power supply. We have output 3, that's going to our direction plus. Then we have output 6, which is going to our enable plus. Then finally we have minus CM1, and that's going to our 24 volt minus. Now while we're on our outputs, I think we're going to want to signal some things just to make it easier than scrolling through the program. So we're going to wire lights 1, 2, 3, and 4. And just looking at one of our getting started guides, we see that one side of all of our lights is jumpered together and goes to the DC minus, which is the right set of terminals. And then the other side goes to our outputs. Now we're not going to be able to use our regular output. So I'm going to connect light 1, which is our green light, to output 5. Light 2, which is our yellow light, to output 7. Light 3, which is our red light, to output 8. And light 4, which is our blue light, to output 9. Okay, so when you're done, you should have jumper wires going from one side of all of your lights. And on the other side, light 4 should be going to output 9. Light 3 should be going to output 8. Light 2 to output 7. And then we're going to have to skip because our enable was on 6. So this is going to be 5. So you should have wires connected to, well, really at this point you should have wires connected to everything except for output 1, output 2, and output 4. Then let's go ahead and look through some of the others. First we have motor and load, and we're going to come back to this one. And then we have limits, and you could have hard limit switches, which we do have, but we have those wired directly to the stepper. And we could get feedback on it, but I don't think that's necessary on this setup. So I'm just going to uncheck our lower hard limit and our upper hard limit. Then we have dynamics, and we're going to come back to it in just a second. And finally, we have homing. And we're going to do our homing a little different. And the issue is this right here is designed for our home switch to be on input number 2, and they don't make it where you can change it. But in our previous video, we configured input 0 and 1 for our high-speed counter, and that was NPN. And so our home switch is PNP, so we need to shift it down some. So we're going to uncheck this box, and we're going to do our homing in our ladder logic. Now, that won't give us probably as precise homing as you would get if you did it in the module configuration, but it's going to get us close enough here, and otherwise we would need probably like a solid state relay, and I don't have a solid state relay handy to do that with. So we're going to take the wire that we connected to our left sensor here, and we're going to need to connect it to our other set of inputs. In fact, let me get a close-up of this so make sure we're clear. We connected encoder channels A and B to input 0 and 1. If you notice, they're grouped. So input 0 through 7 have the same common. And this is connected to plus 24, making these sourcing inputs. Now typically they would be syncing, except for in high-speed applications. So we're going to need to put that home switch over here. So I'm going to connect COM1 to our 0 volt, making them syncing inputs like we normally use. And let's go ahead and connect that home switch to input 8. And again, just like the lights, I think we're going to need some push buttons on this one, just so we don't have to scroll and do a bunch of toggling. So if we look at our typical wiring enough to get started guide, we're wiring one side of all the green contacts, or normally open contacts, to the plus 24 volt. So let's wire button 1, 2, 3, 4, and switch one side of them to our plus 24 volt. And then same as the outputs, we're going to shift them down for this. So let's wire button 1 to input 9, button 2 to input 10, button 3 to input 11, button 4 to input 12, and switch 1 to input 13. So now we should have jumper wires from the top of each of our normally open on button 1 through 4 and switch 1, and all of those are going to our left set of terminals, or our plus 24 volt. And then we have a wire coming out of the bottom of each one of them. Button 1 is on input 9, button 2 is on input 10, button 3 is on input 11, button 4 is on input 12, and switch 1 is on 13. Now let's go back to our motor and load tab. And first we have position units, and so we can define whether we want millimeters, centimeters, inches, or revs. Now in our previous video we calculated revs, inches, and millimeters, so we could use any of those. Now I'm going to stick with millimeters, and honestly, even if you're building a machine that ultimately is going to display inches, but every bit of it is actually millimeters, I would recommend that you do all your calculations in millimeters and at the last minute change them to inches. And the main reason is if we go to troubleshoot, I can really quickly see that, okay, one turn of this screw should be 4 millimeters, and I can get a really quick check. And so there's a lot of easy checks we can do when we're troubleshooting a machine. So we'll leave that at millimeters. And then we have pulses per revolution. Now this stepper here is designed for 1,000 pulses. But the same as our encoder, it counts the A, the B pulses, and the rise and the fall and all that. And I have a video describing all that, but mainly this number right here is going to end up at 4,000. And then we know that one revolution of our ball screw is 4 millimeters. So we're going to put 4 millimeters right there. All right, next tab I skipped over was this dynamics tab right here. And the reason I skipped it is once you enter your motor and load data over here, it's automatically going to figure out what is the maximum that the Micro850 can actually handle. So we could have guessed at these earlier, and there may be some mechanical limitations that we need to put in. So we mouse over them, it's going to tell us the maximum. So the max this would actually be able to run per the stepper is 100 millimeters per second. Now that still seems way fast to me, but let's start with that. And our RPM, the max RPM, it's going to calculate after that. It's going to do a max of 1500 RPM. And then our max acceleration is going to be 10,000 meters per second. I'm sorry, 10,000 millimeters per second. And the same with the deceleration. And finally the same with the jerk. Now in the end, I'm going to set this start-stop velocity to 5, which is going to be 75 RPM. And also we have emergency stop profile, which could be a little different, but I'm going to leave that just like it is. Now we've made a lot of additions to our wirings. This is probably a good point to go ahead and download this program and make sure what we have works before we go any further. So if you need any help downloading your program, look down in the description. We have lessons on how to connect to your PLC, create your first program. We have a whole series on the Micro850 PLC. So just look down in the description for a link to it. Also, while we're waiting on this to download, please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. And I'm going to go ahead and get this trainer spun around where we can see exactly what's going on. Now let's open up our controller variables and let's just scroll to our inputs and let's check all of them. So I'm going to press my green button, which is button 1, and we should see a checkbox by input 9. And then I'm going to press the yellow button and we should see a checkbox by input 10. And now I'll press the red button and we see a checkbox by input 11. Press the blue button. We see a checkbox by input 12. And I'm going to switch 1. And we see a checkbox by input 13. Now our proc switch is an inductive proc switch. And what that means is you can't just stick your finger over it and get it to trip. You need something that has metal in it. So we're going to take our screwdriver and stick in front of it. And we see input 8 come on. Next, we connected an enable to our ball screw. So if we turn on output 6, the screw should move. So right now I can't turn the screw. And I'm going to go up and find output 6 and put a checkbox there. And now I can move the screw. So that means that our enable will work. So go ahead and uncheck that box. And it looks like all of our wiring is good. Now I know everybody wants to see this thing move like right now, but I want to add a few other things first. So they're just going to make our life easier as we run into issues, because you will run into issues with this. And also maybe I didn't stress really important, make sure your limit switches work. So like right now, I cannot turn the ball screw. I hit one switch, I can now turn the ball screw. I hit the other switch, I can now turn the ball screw. If that part doesn't work on yours, it's very important that you get them working for this. All right, but let's go ahead and go offline, and let's go to program 1 and open up the ladder in it. And we're going to bring down an instruction block. And, well, actually, no, let's do that a different way. That way we can see all of the instructions associated with motion. Let's use our tabs up here. Let's use our right arrow and move across, and you're going to find 3 motion tabs. We have the motion event, motion move, and motion state. So the first one I want to click on, well, let's go through all of them. First we have motion event. And so this would be about touch probes, recording something really precise. And we may do that in a later video. Then we have the motion moves, which is what everybody wants to see. You want to see that action happening. And then we have motion state. And so we can use this one to power up our servo, which is what we're going to do in a second. We can also read our axis error information, and we can reset faults. And those are going to be important here. So we're going to bring down this read axis error, MC read axis error. And for this one, I know there's a lot of things on the other side here, but the main ones we're going to be concerned with is first, what axis? And I named that stepper. So that's our axis. And then we have an enable. And this is something that you've got to get used to about all of these motion blocks, is just sticking this here. Even, let's just say traditionally on a ladder diagram, we would go over here and we would find a bit instruction, and this is how we would do it. Well, this actually doesn't enable this part, which is what's going to read the fault. So we're actually going to drop this instruction in here unconditionally, or with nothing to the left of it. And then for enable, I'm going to put true. And this is going to go read the axis state. Now, honestly though, I need to hit F1 on this, because I'm not sure that this continuously does it or if it only does it once. So let's hit F1. All right, and here it's, let's see, let's go down, and true, get value from parameter continuously while enabled. Okay, so as long as I just have true type there, it's gonna go get it all the time. And I think that's fine for what we're doing here. And we're gonna get data from it. And mainly, we're gonna look at this error ID. So now I'm gonna bring another rung down, and we are going to use an instruction block. And I'm going to type NEQ. And for this is going to be MC axis read error dot error ID. And if it is not equal to 0, then I am going to turn on the red light. Now, we didn't label our lights earlier. We made output 5 was our green light. And then output 6 is our stepper enable. And I'm going to type a low at the end of it. That way we remember that when it's off, it is enabled. And then we have our yellow light. We have our red light. And output 9 was our blue light. And same thing down here. I should have put labels. Actually, I should have labeled this in the previous video, because this is encoder A pulse. This is encoder B pulse. And then input 8 is going to be our home switch. Input 9 is going to be our green light. Oops. Now notice in Connected Components you can't have the same alias twice because they do kind of act like tag names. But I put light, that should have been button. So the green button, yellow button, red button, and our blue button. And then we had switch 1. So going back to our program, if our error ID is not equal to 0, we're going to bring down an output energize, and we're going to turn on the red light. So that'll give us a red light if our error ID is not equal to 0, or if we have an error. Going back to our motion state tab, we also had this MSO, and that's how we actually power our servo on and off. So let's bring that down. And actually, here's, going back to these not needing conditions, I can put that on the same rung as our access error read. And, I won't argue either way about whether this is a good idea or a bad idea. But in this case, our access in is going to be our stepper. And then we're going to use switch 1 here. So our enable is going to be switch 1. And then we have a couple other things. It says enable positive or enable negative. And this is a really good feature. Is let's say for some reason in this particular step we only want it to be able to run one direction. Then you can disable it from running the opposite direction. So in this case, I'm going to make both of these true. And to do that, we need to type true because, we talk about ones and zeros being true and false also. But if I type a 1 here, see, we're going to get an error. And that's because it's going to consider this a type of integer, and we need a Boolean true. So that's going to be true. And this is going to be true. Okay, so as little action as we're going to see in this, let's go ahead and download this and make sure that we understand what these two instructions do. And mainly that, yeah, we are enabling and disabling our stepper with this. Now looking at our rungs, first our read access error, it is showing an error ID as 0. So if it's working, then right now we have no problems. And over here on our power, we're showing false, and we're showing false because digital input number 13, which is switch 1, is off. And if I try to turn my screw right now, it does turn since that servo is off. So now I'm going to switch 1. You can see I'm sitting here turning my screw. The moment I switch 1, I can't turn it anymore. And if we look in our program, now we're seeing true here on input number 13, and it's showing that our servo is true and active. So we switch off switch 1, I can turn the screw again, switch it back on, and now it's enabled again. So that gets us through enabling and disabling our servo. So yeah, now let's see if we can make this thing move. So let's go back offline and let's add a few other rungs. Now first, one thing I probably should do is, I think later on we may forget about switch 1, is let's make it that, which one actually says that the servo is on? Let's highlight this MC power in F1. It's going to bring up the help for it. And I'm not sure exactly which one is it's saying it's enabled and which one is it actually on? True indicates function block has control of the axis. State of the power stage. True, try power on is done. I think this is the one we want. So we want that status bit. I'm going to go and we're going to add another rung right below here. And we're going to go to our favorites tab and bring down a direct contact, examine if closed. And we're going to look at this MC power status. So I'm going to type MC, and there's power, dot status, and we are going to bring down an output energize, and we are going to look at our green light. And well, it's only a small step. Let's go ahead and download this and make sure that works as expected. Okay, and right away we have a green light. Switch 1 is a 1. I'm going to switch that off. Green light goes out. Okay, so that's going to let us know now that we have power on that. So let's go back offline. And now let's go back over to our motion tabs. Remember, we had 3 tabs, so we just mainly worked on this motion state tab, figuring out what our error is when we have one and how to turn our servo on. Now we want to do some motion, so we're going to look at the motion move tab. We've got several different things we can use to do some motion. First we have motion axis home, and we're going to do a different version of this in a second. We have motion axis move. We also have a move relative, and then we have this MCD, which is a jog command. And so that's what we're going to bring down. So let's go bring a new rung down and just bring it to the bottom. And then let's bring down this MCD command. And let's talk about what we're doing and why. First, right now, this has no idea where it is. Now, we do have an encoder. And if this was a closed loop motion controller, then it could precisely track position. Well, this isn't. This is a pulse train output. And if you notice in our axis configuration, if we just pop back to our axis configuration here, there is no feedback from this encoder. So this is what we call open loop. And what that means is it really doesn't know where it is. So we're going to use this encoder to do a check on our position, but it doesn't get actual feedback. And even then, if it was a motion controller, then when you power it down, if you were to move it at all, then it wouldn't know where it is. Or even now, if I hit this limit switch and I crank this a little bit, it wouldn't know where it is. So we need to home this or give it a reference point, and that's what we're going to use this switch for. But we can't really do a motion move command because it doesn't know where it is. So we're going to use this velocity command, and actually this is how you would do a general jog also. So looking at our program, we have an axis in, and again, this is going to be our stepper axis. And then, okay, we have an execute command. And so we need to create this. So let's double click on the bottom of that one. And under global variables, let's create one called home stepper. And this is going to be a Boolean data type. All right, and then we have a velocity, and I'm going to put the velocity at 2. Now this is going to be 2 millimeters per second. And then acceleration, I'm going to put at 10. Now I'm really just throwing these numbers in. There's not exactly a rhyme or reason for them. But if you were doing an actual motion application, then you would want to figure these out per mechanical design and everything else. Now jerk has to do with it making an S-type move. So you got trapezoidal moves and you got S-type moves. And we may talk about them in a later video. But for our application, really, a move is a move. So we are just going to put our jerk at 0. And then we have a direction. And our direction, in our case, we want it to go to the negative. Or at least, and you know, we haven't even actually talked about this, and I may have not even hit this in our high-speed counter video, is I want that way to be minus and this way to be plus. And I'll be curious to see if our direction's even right on our high-speed counter. I didn't even think to check that. But okay. Finally, we have this buffer. and we're going to set it to 0. Now that gets us through our rough move. Now don't be gung-ho and just download and think, oh, I'm done, I can close this video now. There are many steps, and in fact, yeah, I guess I should show you what's going to happen if we do this. So yeah, let's just download this program just like it is to show what it will do. Now again, I have stressed, I don't know how many times in this, that you need to have your limit switches hooked up so that you don't run into problems. But okay, we downloaded our program, and yeah, we're gung-ho, and we want this thing to run. Well, so I'm going to toggle this home stepper, which you can right-click right here and select toggle Boolean value, or just hit Control-T. And right away, we got some action. It's all exciting. And we're gonna blow right past that switch because we haven't done anything else yet. And here's why it's important to have your limit switches hooked up and working properly, because there's nothing to stop this except that hardwired limit. And even now, just so we can show this, it's disabled it. I'm gonna grab the screw and I'm gonna turn it back, and as soon as it gets there, it's gonna jerk it back. Because this thing is just gonna keep on sending out pulses forever. So don't be gung-ho. We need to make sure that we have this whole program. So what could we have done there? Well, if you followed all my steps, we could switch that off, and now, yeah, we can rotate this on out. Now, since we switched this off, now I'm going to switch this back on, and notice it doesn't move. Because after you power this off, it has to see a transition in this again before it'll move again. So in fact, I'm going to toggle it off. You see it goes to false. I'll toggle it back on. But yeah, again, have these limits hooked up, because you see we just hit that limit again. But yeah, really quickly, we can switch that off now if we're having trouble. And yeah, every time you're going to have to roll this thing back out, at least until we get it working out. So stay for the whole video, and yeah, let's see if we can figure out how to make this do some controlled motion. But okay, what do we want this to do? So we have a home switch. We want it to come up here, and then we definitely want it to stop there. And we also want to register this position. So let's go back into our program, and let's go offline. And we're going to need a few more commands. First, we need to home it, and we're going to home it with this motion axis home right here. So drag it down, and then our axis each time is going to be this stepper. Now we have an execute, and let's create a tag for this. And for now, let's just call this home M-A-H, and that will be a Boolean tag. And then we have a position, because what we could do is we could say that when you hit whatever your home is, we could have an offset here. But for our application, we're going to want this at 0.0. Now, the most important thing of this is the type of homing here. And for it, let's hit the F1 key. That way we can see the different types. And mainly this homing mode right here is what we're looking at. If we scroll a little further down, we're going to see our homing modes. So we could be searching for a switch. We could be looking for a limit switch, but remember we had our logic issue with that. We have NPN inputs, the way ours is set up, and we have a PNP switch. So we moved ours out and decided we'd do it in ladder, and we're going to use this static homing process for direct forcing of a home position from user reference. So what this is going to do is it's going to put it wherever you tell it when you tell it. So we're going to use a mode of 4. Now that'll get us home, but we also need to stop this at that point, because otherwise this thing is just going to keep on running off of this move velocity. So we are going to also bring down this MAS right here, motion stop instruction. And for our axis, it will be our stepper axis. And execute, well, we need to create something for that. Let's just create a tag, and let's call it home MAS. And that will also be a Boolean tag. And then we're going to need a decel for it, because we have to tell it how slowly to stop. And I'm going to put 10.0 just because that's what we put earlier. And our jerk is going to be 0. All right, now I put all these in the same rung, mainly because this is part of our homing. We'll call it our homing sequence. You could put them in individual rungs. It doesn't really matter, because mainly this execute is when they're actually going to happen. So now we need to put some code in to actually use these, because you know I had to toggle this. And yes, I have had a wardrobe change. I had to start our PLC training. So it is the next day that we're finishing this up. But we've got our 3 commands here. We've got our move velocity, which should get us moving towards our home switch. We have our home, which should zero out our position. And we also have our stop. And actually, they're not going to be in that order, because we're going to home. Then let's drag this one over just for a little sanity. Then we're going to stop, and then we're going to home. Now, one thing also, we do have a way of knowing that we need to home. If we go to our controller variables and we open up our stepper, then we have this axis homed indicator here. So let's make the blue light our home indicator. So we're going to add a rung, and we'll do it right above those instructions. And we're going to use an examine if off, reverse contact. And let's look at that stepper axis homed. So when it's not homed, let's turn on the blue light. Oops, IO tab. And we're going to turn on the blue light. All right, and then let's use the blue button to start our homing process, because we're going to need to do some basic stepping through these. So we'll bring down another rung and examine if on. Let's look at that blue button, which we have wired to input number 12. And then with that, let's latch our home stepper bit. All right, so that's going to get our axis moving in the correct direction. And then the moment that we see our home switch, so let's bring down another rung. And first let's look that we're homing our stepper. And then let's look for that home switch, which is going to be input 8. And when we see those, first we want to stop our axis. So let's bring down, let's latch our motion axis stop, and then let's unlatch our move stepper that was making that action happen. Okay, then we need to know that our axis is stopped, and we can use this done bit to do that. So we're going to look at now that we are stopping. And that we have the MC stop.dn. Now this MC stop 1, that was created when we brought down this MAS instruction here. See, it says MC stop 1. So that's where that came from. Now there was a timing issue when I tried this out, so we're going to add a small intermediate step, and maybe somebody can refine my code for this, but what I found out is if you immediately stop and then try to home, it came up with an error when it tried to home. So what I'm going to do is first I'm going to latch a bit, and let's just call this our home stop delay. And then we're going to unlatch our stop, our home MAS, which will stop that instruction. And then along with that, I'm going to put a timer here. So I'm going to insert a branch below and add an instruction block. And we're going to use a TON, timer on delay. And we're going to use a preset of T number 1S. And also over here, whoops, not there. Let me see, can I just drag that over? Yep, there we go. And also we're going to keep this timing as long as that delay that I just had, that home stop delay, is going. So this way, once we are stopped, when it's going to latch this home stop delay, it's going to unlatch this motion access stop, and then it's going to start this 1 second delay timer. And then let's bring down one more rung. And this time we're going to look that our home delay is done. Our home stop delay is done. And when it is, we are going to latch our motion access home, our MAH. And actually I said that was the final rung, but no, we need to unlatch that when it's done. So we're going to bring one more rung down, and we're going to look that home MAH is on, and then we're going to look that the MC home instruction, so MC home1.dn, and when it is done, we're just going to unlatch that home bit. Okay, so that should do it. Let me check these latch unlatches, make sure I got it. Okay, well first, all right, first rung, if we're not homed, blue light should be on, and we press the blue button, it's going to latch our home stepper, and ultimately our home stepper is going to execute this move velocity. And once we see our home switch, it's going to latch our stop, and it's going to unlatch this home stepper, and that's going to execute our stop command right here. And then once our stop is done, we're adding this one delay, and that's going to latch our delay. It's going to unlatch that stop. And then once our stop delay is done, we latch, we latch our motion access stop, but we should unlatch our home stop delay there. So I'll bring down that, and let's bring down an unlatch. That will be our home stop delay. There we go. And then once our motion access home is done, we're looking for it to be home, and then we unlatch that. Now that is a lot. So let's just download this program and see how it works. This may be one that it's easier just to do the code and then walk through how it works. If I program this right, then first we have a blue light now. And so our blue light means that our system does need home. And when I press this button, the carriage should start to move back this way and stop on this switch. So I'm going to press the blue button. It does start moving back, and it stops on the switch. And now let's look at our program here and see. Okay, and it does look like everything happened. So let me hit the blue button again. In fact, let me move it off of this so we can see a little bit of the timing of this. I'm going to hit the blue button again. We see that it starts homing. The home switch got hit. And yeah, okay, it all did happen really fast, but then it commanded this motion access stop, which gave us that 1 second delay. And honestly, this is where my program can be refined, as I couldn't figure out, I could not immediately execute this home instruction right here, right after the stop. And it didn't seem to matter if I was moving or not. I just had to have a delay here. So there's some timing issue there, but that does get us so that we should be home. Now, how do we know we're home? Well, first our blue light went out. And we should also be able to check our position now. So if we go to our stepper and looking at our position should be 0 now. And yes, our position is 0. So now we're ready to move somewhere. So let's go ahead and put one more line of code in here. Let's go offline. And then at the very bottom of our program, let's insert a rung. And we are going to look at our green button. Yeah, because we haven't used our green button. And this is going to execute our move. So we'll go down and select our green button. And also we want to make sure we're homed here. So let's look at that stepper homed. So stepper, we want our axis to have been homed. And then let's bring down an output energize, and we are going to energize our stepper move. And we'll need to create that. So stepper move, and that'll be a Boolean tag. All right, and now let's bring down another rung. And for this one, let's go over to our motion move tab. And we're going to bring down an MAM, which is a motion move. All right, for our axis, it's going to be that same stepper axis that we've used on every other one. And to execute it, we're going to use that stepper move that we just created for the previous rung. Now for our position, we could just put in a value such as 10.0, and that should move at 10 millimeters. But let's make it where we can change this. That way we can use the same motion axis move to move it to different positions. So let's create a variable, and we'll call it stepper position. Oh, actually, let's make that a little more descriptive. How about a stepper move position? And then the data type for it will be a real. Stepper move position. And if you're not sure about the data types, I'm sure I've said this already, but you can just mouse over this and it'll tell you all the data types. So we have a velocity, and let's do the same thing. Let's create a variable for this. In fact, while we're here, we could create all of these. So we have stepper move velocity, and that's going to be a real. And then we're going to have stepper move accel, and that's going to be a real. And stepper move decel, that's going to be a real. Let's see where that gets us to. So this one right here is stepper, whoops, nope, it's stepper velocity. So we'll go back, and this is velocity. And then we have our acceleration, which will be stepper move acceleration. And then we have our deceleration, which will be stepper move deceleration. And then for the jerk, we're not using that because we're just using a trapezoidal profile. So we're going to put 0 for the jerk. And then we have a direction. Let me F1 on that and make sure. But our direction is, oh, the parameter's not used. And buffer, this parameter's not used. Well, cool. So we don't have to put in anything for those. That's great. All right, and I think that'll get us moving. So let's go ahead and download this program. All right, so we're back online, and we should be able to just hit our green button. Oh, nope, wait. Our axis got to be home. So once you download your program, your axis will have to be homed again. And yeah, we can even see it here. We have a blue light, which means we need to be home. Now we're sitting on the carriage, and somebody will probably bring this up, is this switch can be a wide variety. So that's where you'll usually see one do a little bit of move, and there's some options in there to home. But for our purposes of this demonstration, if we're on our switch, we're calling that good. Okay, so we have that, and our axis is homed. So we should be able to hit the green button and make this move. Now, we do need to put a position. Actually, we need to put some values into all of these. So let's just open them up. So our stepper move position, let's move 10, we'll call it units. I believe it's millimeters. Actually, since it's a 4 millimeter pitch, let's move it 4 to start with, and that should be 1 revolution. And then for our velocity, well, let's just make it 4. That means it should take 1 second to run, I think. And then we're just going to put 10 for an accel, no particular reason. 10 for a decel, really for no particular reason either. All right, so that gets us values in all these. So now, if we hit our green button, we should see some movement. Okay, we did see movement, but we saw way more movement than I expected. All right, we had in a move position of 4. Well, first, where does it think that it is now? So let's go back to our controller variables and look in on our stepper. Okay, and this target position it thinks is 4, but that sure seemed like a lot more than I expected. So let's try moving another 4. Let's go to 8, just so we can see that again. So I'm going to go to our program, and we'll put a move position. And we're going to make this 8, because these are absolute positions. And let's slow this down. Let's make the velocity 1. And at least by my thought, this should have rotated 1 time. And we can see those set screws there. That's a good reference. And I'll hit the button. 1 revolution, 2 revolution, 3 revolution. Oh, that was 4 revolutions. Well, okay. Maybe we need to hit that help thing again. Now, I would have thought that this position would have been in millimeters, but okay, let's highlight an F1 and let's look at this position. And our position, target position for motion and technical unit, negative or positive. Each technical unit is defined by motion general tab. Okay, well, let's look at our motion, and we'll go to our stepper and our general tab. I didn't think our general tab had anything about it. I think of motor and load tabs where we need to be. Okay, Matt, you know something? Was I wrong on this 4,000? I kind of think this, because I'm off by exactly 4. And this is 1,000 pulses. I think I'm wrong. I think I was wrong when I told us to put 4 in here, thinking that it would quadrature. I think this 1,000 pulses is 1 revolution. I think this does need changed. So let's go offline and go back into our stepper configuration, motor and load. And yeah, I think I got wrong here. I think this should have been 1,000. So we'll download that. Okay, and all right, so first we have a blue, so we need to home. That turns the servo off, so we turn the servo back on, and we hit our home. And we should stop on our switch again. Remember, you can use switch 1 to turn it off if it doesn't stop. Okay, and we did stop. And now we'll look at our motion move. And you know, and should have thought about this. Our initial values, I should have put some in here because we're going to need to change these again every time we download. So I will put a position. Well, okay, at this point, well, no, it should be 4. 4 should be 4 millimeters. So we're going to put a velocity of, well, really 4. 4 should take 1 second. And then our accel is going to be 10. And our decel is going to be 10. And that should get us moving. So now we'll be looking at these set screws, and it should take 1 second. We should go 1 revolution. So 1 1,000. Okay. There we go. We're cooking with gas now. So we moved 4 millimeters or 1 revolution. At this point, we should check it because we also have an encoder out here, don't we? And we need to zero our encoder. So we didn't do that. So let's open up our structured text program. And right here is what we wrote in our previous video to determine, well, to configure our high-speed counter and determine our position. So if we just hit our F1 key and let's just type HSC, let's just type HSC, enter, and see what we come up with. So we got our status, we got our app, and right here we have our command. And so our command, this tells you what the different commands are that we can send this. And we have it as 1 right now. And if we send it a value of 4, then we can change the accumulated value. So that's what we're going to do. is first we're gonna create a conditional if. So let's add a line right at the top and type if, and then we want that home MAH, which is how we're zeroing our stepper. Then, and let's hit enter for our next line, and this will be encoder command colon equals 4 colons, semicolon. In fact, this should look almost like what was our first line, except for we have a value of 4. Now that's going to give it a command of 4, but we also need to enter an accumulated value, because if you just tell it 4, it's going to set whatever's already in the accumulator to the new accumulated value, which is going to be doing nothing. So now we need to enter accumulated value. So that's under our app. So encoder app dot accumulator colon equals, and we want 0. And here, same as with our motion access home, we could put a position here and change it to something specific, but we just want 0. Now else, which pretty much means when we're not homing, then we want that, actually we want that next line, which was our original line. Encoder command will equal 1. So then after encoder command equals 1, enter end if. Okay, how many semicolons did I miss? I think I just missed one right at the end. I'm famous for missing those, but yeah, I think that's it. So let's download this and see what it does. Okay, now let's open up our controller variables and let's find our encoder position, which is down here, whether you're looking at the revs, the millimeters, or the inches, and they're all 0 right now. So let's go ahead and let's move our axis a little bit. So I'm gonna hit the limit switch, and we're gonna roll that. Ooh, and I already see a problem. We didn't catch this earlier, but that's okay. Let's ride this out. So now what we need to do is we need to home our system. Oops. Okay, so need that on. We're gonna hit our home button. And actually, let me get over where you can see the screen. So now we're looking at these values here. And mainly, when it gets to the stopping position, they should go to 0. Okay, and they did. So now our encoder is zeroed. And if we look down at our stepper, then its position is also zeroed. And since we have them both scaled for 4 millimeter, then they should match all the time. So let's go back to our program and go down to our move, and let's put some values back in this because we downloaded. And yeah, we probably, if I can remember one of these times, I'll put a logical value in when we're offline. But so we want a position of 4 because that's going to be 1 revolution. And let's stick with the speed of 4 because that's going to be 1 second. And then let's go with an accel of 10 and a decel of 10. All right. So now when I hit the green button, we should see our value here go to 4, our position here, and we should see our position up here go to 4. So I'm going to hit the green button, and we did move, and we are at 4.06, except we are negative here. So there are a couple ways we could fix this. As first, we could go into our program where we did all of our math here, and we could simply put a times -1 somewhere. But probably the more common way, because you change an encoder and maybe it's running backwards. Well, we don't want to change our program every time. The same as you put a new motor in, sometimes it runs backwards. Well, what do you do if a 3-phase motor is running backwards? We're going to reverse 2 wires. Well, you're going to do the same thing with this. So I didn't catch this in the earlier video, but I have my A and B swapped. It's tracking the wrong direction. It's tracking accurately, but this way is negative and that way is positive. And we've set this up so this way is positive and that way is negative. So on our Micro850, we connected our encoder to input 0 and 1, channel A and B. Now if we simply swap these two, it'll swap that direction. So I've swapped them, and so now, first I'm going to home it again. So let's go, and let's look at that value again. So right now, here's our value. I'm going to press the home button. All right, and it has gone back, and yeah, it's showing really, really close to 0. And if we scroll down on our stepper, it's showing really, really close to 0. And so now, if we hit our green button, it should go to 4 millimeter. And now it's showing roughly 4 millimeter here. And if we scroll down to our stepper, then it's showing roughly 4 millimeter there.